Hello, hello! This video is dedicated to chemical energetics. Yeah, it is another topic that may be seen as complicated in this video, but let's just spill some tea and discuss chem in easy mode, so even my dog will be able to understand how enthalpy change works or how the heck to solve the problems given in these tests. So I hope we already know what endothermic or exothermic reactions are, but let's quickly go through it. The key to your understanding is that you can think of the energy as heat. Endothermic reactions take this energy to themselves, like a hamster devouring your homework. It means that there is less energy in the surroundings. As energy is heat, it means it becomes colder. Easy, isn't it? And so, formation of bonds releases energy the atoms had before making the reaction exothermic. Why? Hmm. Here's a metaphor using a conservative example. When a person is married, he or she has much less energy to do anything. People travel less and stay at home most of the time, unlike it was before they were bound with this relationship. So, when bonds are formed, compounds are more stable and don't require that much of energy, and the energy is being released. On the other hand, exothermic reactions release energy from broken bonds of the reactants and by forming more of them in the products, which leads to the increase in heat. The examples are combustion or burning of something. I hope you know that fire is hot. So hot equals heat equals the release of energy in the surroundings. It happens as for the creation of new bonds, less energy is required than from the starting reactants. So let's come closer to the topic. First, you need to remember one term, enthalpy. Enthalpy is the energy stored in a compound. It is used with the symbol H. But what the heck does it mean in practice if you can't even measure or calculate this energy? Why is it called that? Why is it in chemistry and not physics? Why do I do this? Well, at this stage and level, you don't need to know that much, so just take as a fact that it is considered as a mix of two energies, the electrostatic potential energy, which is a measure of potential energy between two charged particles, and kinetic energy stored by movement of the particles. Most of the time, we will be using enthalpy change, and this is actually what scientists are able to measure and what, my dears, you will have to work with. So I hope you didn't forget what was explained a minute ago. The main feature is that if enthalpy change is positive, it means that the mixture of whatever was there took energy inside and stored it there, which is an endothermic reaction. When there is a release of energy, as in exothermic reactions, it signifies a decrease of energy in the products in comparison to what was in the reactants, and when you will use math and calculate the change, it will be negative. So negative H means that energy was released during the reaction to the surroundings. And as the tip, remember the logic. Negative enthalpy change signifies an exothermic reaction, and positive H signifies endothermic. Here we are, and you will see many reaction pathway diagrams while studying this topic and will have to describe them in your lovely exams. But it's actually easier to understand it through the exam questions. There are two arrows, energy and reaction process. If you've seen this kind of question before, you've probably noticed that reactants level is higher than the products with some kind of a roller coaster. The roller coaster is always higher in reactants at the beginning, signifying the amount of activation energy taken to break the bonds and started happening. And then, if the slope slides lower than reactants level, it means that it lost energy and that it is an exothermic reaction. If products' energy becomes higher, it means that they have more energy inside than reactants had before. Thus, the enthalpy change will be positive. Wow, you're still here? Sorry, teammates, for making it boring, but to be fair, from now on we will go harder and harder. So, take a break and watch part 2 and 3 if you need it. Happy exams, guys!